Hello. Today we're going to review the central and inscribed angles in a circle. But before we begin, let's make sure we know the different parts of a circle. We will start with what we need to know for today, and we'll add more as we need to. So if you look in your packet, you should see a circle geometry chart with the type of angle, the diagram that you're going to need to draw, the written definition, which is fill in the blank, and the formulas with the angle. So if you flip that over, you can start to look at the parts of the circle. First off, a circle is the set of all points equidistant from a given point called the center. And all the angles in a circle add up to 360 degrees. So if you take a look, a chord, like it is in the picture here, is any segment that has endpoints on the circle. So each endpoint is actually lies on the circle. The radius, which you should have seen before, is any segment with endpoints that are the center and a point on the circle. And the diameter is a chord which passes through the center of the circle. Okay, so a central angle is any angle that goes to the center of a circle. So it's an angle whose vertex is on the center of the circle and whose radii are the sides of the angle. An inscribed angle is an angle that goes to the edge of the circle. So it's an angle whose vertex is actually on the circle and whose sides are chords of the circle. And again, all angles in a circle add up to 360 degrees. So now let's take a look at the central angle. Again, a central angle is an angle whose vertex is at the center of the circle and whose sides are radii of the circle. And the equation for a central angle is just that of the arc measure. So the central angle is equal to the measure of the arc that it intersects. So 69.5 degrees is the measure of this angle as well as the measure of this arc. And again, you can move it, and if we could actually measure this arc with this software, you would see that it moves along with the measure of the angle. And again, central angle is equal to the arc, measure of the arc. Measure of the arc that it intercepts. An inscribed angle. Again, the vertex is on the edge of the circle, and the sides are chords of the circle. And as you can see, if we grab one of these endpoints, the inscribed angle, which is this angle here, seems to be about half that of the intercepted arc. Now, there are three cases in which you may see a inscribed angle. The inscribed angle can look like this, in which the center of the circle lies in the interior of the angle. There's the inscribed angle in which the side goes through the center of the angle. There's an inscribed angle in which the chord actually goes through the center of the circle, or making a diameter. And then there's also the inscribed angle in which the center lies in the exterior of the angle. Doesn't matter which kind you see, it is going to be the same formula, which is inscribed angle is equal to 1/2 of the intercepted arc. Okay, so now let's take a look at some examples. Again, as you were following along in the previous section, you should have been filling out your central and inscribed angles for day number 1, which is the first part of the first page in day number 1 of your packet. On the back of that is some central angle and some inscribed angle examples. So let's take a look. In circle O, AC and BE are diameters. Measure of angle DOC is 40 degrees, and the measure of arc AE is 80 degrees. So they have that filled in for us. So we need to find the measure of arc ED. Measure of arc ED. So we know that the central angle is equal to the arc. So here, angle AOE would be 80 degrees. Now, if the number of degrees in a circle is 360 degrees, we know that the measure of a semicircle is 180 degrees. Well, we know that we have 80 degrees and 40 degrees here, so we need to add up to 180 degrees. So we're going to have the measure of arc ED is going to be equal to that of this angle. It's equal to the measure of angle EOD, which is equal to 180 degrees minus 80 plus 40 degrees. So we're going to get 180 minus 120 degrees, or 60 degrees. So the measure of arc ED is 60 degrees. Measure of angle EOD is also going to be 60 degrees, which we have here. Measurement of angle BOC. So let's take a look. BOC, again, because this is a diameter, the measure of this arc and this angle, because it's a straight line, is going to be 180 degrees. We have 60 degrees and 40 degrees. So the measure of angle BOC is the 180 degrees minus 60 plus 40 degrees. And we are going to get the angle measure of, which is 80 degrees. Let's go ahead and fill that in. Part D, measurement of angle AOB. Well, same thing. This is the diameter as it's said in our directions. So this is going to be equal to 180 degrees. We have 80 degrees here. What's left? 100 degrees. So the measurement of angle AOB is going to be 100 degrees. Measurement of arc AB is going to be, again, central angle is equal to that of the measure of the arc. So the angle is 100 degrees. The arc is also going to be 100 degrees. Measurement of arc BAD. So we have to follow the letters. So measurement of arc BAD. So we're going to have to add up all of these central angles, the three central angles, to come up with that measurement. Is equal to, so it's going to be the measure of the angle BOD. It's going to be equal to the measure of BOA, which is 100 degrees, plus AOE, which is 80 degrees, plus that of EOD, which is 60 degrees. So let's just make sure we have BA, which is 100, AE, which is 80, and ED, which is 60. And we are going to get 140 degrees. Measurement of arc DBE. So DBE. DBE. So we can go ahead and add up all of these angle measures, or we can think. We know that the number of degrees in a circle is 360. DBE, the only arc not included in that arc, is ED. So why don't we just subtract our 60 degrees from 360 instead of adding all of those angles up. You can also add up all of these angles if you wish. So we're going to get the measure of arc DBE equal to 300 degrees. And that's it for the central angle example. So let's take a look at the inscribed angle example. So we have triangle ART is inscribed in circle O with the measurement of RT 86 degrees. Find the measure of angle A. Well, we know that an inscribed angle is equal to 1/2 that of the intercepted arc. This angle intercepts this arc. So the measure of angle A is just going to be 1/2 that of the measure of RT, which makes it 1/2 of 86 degrees, which gives us 43 degrees. Measure of angle R, well, once again, since this is a diameter, because it goes through the center of the circle, we're going to know that this arc is 180 degrees, because the measure of a semicircle is 180 degrees, since the measure of this central angle is also 180 degrees. So the measure of angle R is going to be that 1/2 of the measure of arc AT, which gives us 1/2 of 180 degrees, which gives us 90 degrees. So measure of angle R we know is 90 degrees. Measure of angle T. Well, considering this arc is the only arc we have yet to measure, we know that it's going to be out of 360 degrees. So the measurement of angle T is going to be 1/2 of 360 minus that of RT, arc RT and arc AT. So 180 plus 86. So it's going to be 1/2 of 360 minus 266. So it's going to be 1/2 of 94 degrees, which is 47 degrees. Measurement of arc AR is going to be, so we know that the inscribed angle, which AR is the intercepted arc, so it's going to be angle T, so 47 is equal to 1/2 the measure of the intercepted arc. To get rid of this 1/2, we're going to multiply both sides by 2. We are going to get 94 degrees is the measure of arc AR, which we figured out to figure out the inscribed angle. Again, you could have also figured out the measure of angle T. You know this is a right, you know the triangle, there's 180 degrees here. So you had 90 degrees and 43 degrees, so you could have subtracted 180 degrees minus 43 and 90 degrees. So that's going to be it for your video today. Thank you.